Okay, now we're starting the proof of the converse direction of our theorem. We assume that in our norm space X, every absolutely convergent series converges, and we have to show that the space X is complete. So by definition, that means we have to show that every sequence that is Cauchy converges. So let curly braces X of n be a Cauchy sequence. I have to show that it converges. Show the sequence converges. But now we use a trick in convergence to show that a Cauchy sequence converges. It's enough to show that there's a convergent subsequence. So it suffices to show that there exists a convergent subsequence. This is an elementary technique in metric spaces or norm spaces. To do this, I'll have to apply the Cauchy condition to the sequence, but I'll have to do it infinitely often. Let's start. First, I choose an n sub 1 in the natural numbers such that the norm of x of n minus x of k is less than 1/2 2 to the minus 1 for all n comma k greater than or equal to n sub 1. So what I did was I applied the Cauchy condition to the sequence x of n with epsilon equals 2 to the minus 1. And I found an n sub 1. I called it n sub 1 because I'm going to do this for every natural number. This is just the first one. Next, I choose n sub 2 greater than n sub 1 such that the norm of x of n minus x of k is less than 2 to the minus 2 for all n comma k greater than or equal to n sub 2. To see why this is possible, first forget about the condition being bigger than n sub 1. I've just applied the Cauchy condition for epsilon equals 2 to the minus 2, so I found an n sub 2. But then once you find one n sub 2 satisfying that Cauchy condition there, any bigger n sub 2 will still work. So now I increase it if necessary so that it's bigger than n sub 1. And now we can keep on going. Continue inductively. Let's show one more. Choose n sub 3 bigger than n sub 2 such that the norm of x of n minus x of k is less than 2 to the minus 3 from all n comma k greater than or equal to n sub 3. I can do that for the same reason as I can choose n sub 2. So every time I choose the next n sub k, this tells me how to choose the next n sub k plus 1. So we continue inductively.